Welcome back. It's Mr. Osborne here. Welcome back to session 2 of fractions. Thank you for joining me. I'm just going to show you. If you remember, I was saying I really enjoyed making Lego. Check this out. This is Lord Voltron. I love this Lego. Mrs. Osborne doesn't so much. She hides it away. Anyway, that's enough about me and liking Lego. Let's get the session underway. And while I do that, I hope you're very well. And here we go. Right, okay, wonderful. Get me in the corner so I'm hidden away there. You don't really need to see me. And let's get this session underway. So today you will need a pencil, paper, and a ruler if you have one. Not to worry if you don't have a ruler. Pencil and paper is essential. I was just thinking, actually, when you finish these sessions, make sure you're keeping hold of all the work you've done, because in the future, when it comes to SATs, possibly, these pieces of paper will come in very handy. Just help jog your memory. Let's move on to the warm-up for today to get our brains working and get us into gear. Now, all I'm going to say to you is, obviously, you don't need to draw these down. You can if you like. If you're going to draw them, you'll take a little bit longer, but that doesn't matter. Pause the video if you need to, and then just match up the pictorial fraction to the fraction that is written down. Okay, give you 30 seconds, then come back to me. Okay, fantastic. You're back already and raring to go. I can't get used to these pauses. Okay, so let's have a look at probably, I would say, the easiest one there, which is a half. No doubt you would have all gotten that correct. If I'm gonna go for something I think is slightly easier than the other two, I'd probably choose the quarter out of this one. Gone for the 1/10 just because my animation's doing it, and then we have 2/5. Okay, just double check that you've managed to do that. Okay, give yourself a pat on the back if you did. Well done, and hopefully your brain is now warmed up and ready for today's fraction session. So I can hear you saying, what are we learning today? Well, today we're learning to understand and identify equivalent fractions. Okay, now I will go into more detail in a second about what the word equivalent means, but basically we're looking at fractions that have the same value. So they may look differently, they may look different written down, but they have the same value. And essentially that's what we're going to be doing today. Okay, like a good animation. Here we go. So some key vocab, and hopefully you would have remembered this from last time, but nevertheless it's always important to have a look. So when we're talking about fractions, we are talking about a part of a whole. So we're talking about parts of whole. So here we have the numerator and the denominator. Now the denominator is how many equal parts the whole has been divided into. So we have our pizza here. We have one whole pizza that has been divided into 4 equal parts. It's always important to remember it's equal parts. And in this example, we have 3 quarters. So we can see that 3 parts, equal parts of this pizza have been highlighted. Okay. Proper fractions, I know you'll remember that from last time. That is when we have the numerator is less than the denominator. Okay. And then finally, really important today, strange animation. What does equivalent mean? Now in math, equivalent fractions can be defined as fractions with different numerators and denominators that represent the same value or proportion of the whole. So put a bit easier, let's just say it is different fractions with different numbers have the same value. That would make them an equivalent fraction. Okay, if you're not quite understanding that, not to worry, because hopefully at the end of the session you will have a good grasp on that statement there. Okay, and then just a red just the red animation coming in. Right, let's move on. Okay, so what does equivalent mean? As we took from that statement, that it is fractions with different numerators and denominators that represent the same value. Now, hopefully in this picture, this will help to guide your understanding a little bit more. A fraction in the middle, we all know as a half, and a fraction to the left, we have 2/4, we have 3/6 and 8/16 there. Now, all of these fractions are equivalent fractions because they're all equal to a half. Okay, now this can be carried out by simply multiplying the fraction through. Now, we'll go through this technique in a minute, but I just simply want to show you that this half, if I was to times this half by 2, I would then end up with 2/4. If I was to times this half by 3, would give me 3/6. And then if I was to times this by 8, so it's 8 times bigger, I would end up with 8/16. Okay, now it's really important in fractions to remember that whatever we do to the numerator, we do to the denominator. Okay, so as you can see, when I'm timesing by 2, I'm doing 1 times 2 to give me 2, and 2 times 2 to give me 4, or 1 times 3 to give me 3, and 2 times 3 to give me 6, and so on. Okay, equally, when we're talking about equivalent fractions, we may be multiplying, but we also may be using division. Okay, and that is just showing the inverse operation there. So we have the 2 divided by 2, which gives us 1, the 4 divided by 2, which gives us the 2. Okay, so it's 2 times smaller. Okay, but what really we're trying to get to the essence here is this 1/2, so 1/2 is of exactly the same value as 2/4. Okay, let's continue to sort of work through this to make sure we've got a good understanding of what equivalent. Okay, let's move on. So what fraction of the shape has been shaded red? Well, let's have a look. So this shape, we have our one whole that's been divided into 3 equal parts. So we know that there's going to be a third. We've got 1 part shaded red, which gives us 1/3 of that shape shaded red. Let's look at the next shape down. We've got 2, 4, 6 parts to that one whole. So we know that that is 2/6 of that shape has been shaded red. And then finally, we have 4, 8, 12 parts. So that one whole has been divided by 12 parts. And I can count 1, 2, 3, 4. 4 parts of that shape has been shaded red. Now let's just pause for thought here and have a look at what's happening on the screen. If we take a look at our numbers, actually, it's a good idea to be thinking about what's the pattern within those numbers. Now, if I have a very quick look, I'm seeing 3, I'm seeing 6, 12. So I'll be thinking about my multiplication tables and thinking, where do those numbers maybe link together, meet up, or fit together? On the other side of the diagram, let's have a look at the picture. Now, the picture has stayed exactly the same. So it's interesting. It's interesting to look at the numbers where we have different numbers, but actually the picture has remained the same. I think let's move on and investigate looking at these numbers and the relationship between the numbers. Okay, so let's take 1/3 and 4/12. Okay, now what do we notice about these two numbers? What are the relationships that we can see? Now, straight away, I'm going to have a look at my numerators. Okay, now I can see my numerator is 1/3, so I've got a 1, and my numerator down here is 4/12. So I know that that is actually 4 times larger. Now, let's take a look. Our 3, so our denominator, we have a 3 there, and a denominator in our second fraction, and we can see that actually that is also 4 times larger. So this relationship tells me that these two fractions are equivalent fractions. Okay, so 1/3 is an equivalent fraction to 4/12. Okay, And here we go. If we remember the statement, go back to this statement. So the equivalent fraction can be defined as fractions with different numerators and denominators. So we can see that we've got our 1/3 and we've got our 4/12. So they are different numbers, but the value of these two fractions would be exactly the same. So if someone was offering you 1/3 of a cake or 4/12 of a cake, you'd be getting exactly the same amount of cake. Okay, so are these fractions equivalent? Yes. Okay, have a go. I'll give you 30 seconds. Have a look at the relationships. What relationships do you see between these fractions? Are these fractions equivalent fractions? Okay, so I'm looking at 6. I'm looking at 12. I can definitely see there's a relationship there. I'm looking at 2 and I'm looking at 4. This is very simple for a good year 6 mathematician. Okay, I can definitely see it is 2 times larger. 2 times 2 is going to give us 4, and then 6 times 12 is going to 6 times 2 is going to give us 12. Okay, therefore these must be equivalent fractions. Okay, hopefully you're getting a good idea now of what equivalent fractions look like. Here's 3 different sets of fractions. I've made this first one nice and easy. If I was to look at this first one, I've got 10 and 20. I've got 20 and 40. Okay, for them to be equivalent fractions, we do exactly the same with the numerator as we do with the denominator. So therefore 10 times 2 would give me 20, and 20 times 2 would give me 40. So I'm happy that they are equivalent fractions. Okay, pause the video there, have a go at the 2 other questions, come back to me in a couple of minutes and see if you've worked out whether they are equivalent fractions or not. Okay, you're back already, fantastic. I'm hoping you've managed to get a grasp on whether these are equivalent fractions or not. Let's take a look. So we've got 5 and 15. So I know 5 and 15, the relationship would be 3 times bigger. So 15's 3 times bigger. Oh, there's times 2 down there. So we have a 3 times bigger, absolutely, and 15 and 45. So you may have written your 15 times tables down here, or you may be really good and know, actually, that is 15 times 3 does give me 45. Let's have a look at our final pair of fractions over here. We have a 2 and 16 and a 4 and 20. So if I was looking to multiply 2, I know that I'd be multiplying it by 8 to take me to 16. Therefore, 4 would need to be multiplied by 8, which I'm not happy with here. I don't think this is a no, and we can see. So 4 times 5 would give me 20. So identify the equivalent fractions. There's only one non-equivalent fraction here, which is this one on the end. Okay, now we're getting good at this. How about using division to find your equivalent fractions? So nice and easy down this end, 30 and 60. These look very familiar to 15 and 30. Mr. Osborne made it nice and easy for you today. So 30 divided by 2 and 60 divided by 2 would be giving us an equivalent fraction. So 2 and 9 and 6 and 18, 1 and 2 and 12 and 24. Have a look at those fractions. Take 30 seconds, pause the video if you need to, and then come back and we'll look through them together. Okay, you're telling me you're done already, which is fantastic. So 6 divided by something is going to give me 2, I believe it's 3, and 18 divided by 2 gives me 9. So is this an equivalent fraction? We know it cannot be an equivalent fraction because there is not the same value of 18 and 9 is divided by 2, whereas we need to do the same with the numerator as we do with the denominator. And we can see at the top, our numerator is divided by 3. So therefore, that cannot be an equivalent fraction. I'm sure I've got an animation that will show that in a minute. 12 over 24, I'm sure you know that's a half. And there you go, there's that animation there. Okay, By now, I'm hoping that you really have got a grip of what equivalent fractions are. Here's a couple more. Pause the video if you need to. Come back 30 seconds time and we shall look through these together. Okay, so you're ready to look through. Again, I just really want to, at this point, actually highlight how important, I said it before in a couple of sessions back, how important your times table knowledge is, especially within fractions. Okay, if you want to be recognizing these equivalent fractions at speed, that means without writing them out, your times table knowledge needs to be really good, which I'm sure it is because you're in year 6. Okay, but just have a look here. So 8 and 16, we know it's going to be times 2. 3 and 6, we know that's going to be times 2. Okay, let's have a look at our 2/4 over 12 over 28. Okay, so writing out my times tables if I didn't know. My times 7 times tables here, and here we go, times 6. So 4 times 7 would give us 28, whereas 2 times 6 is going to give me 12. So that cannot be an equivalent fraction. Okay, so Mr. Osborne has done a lot of talking and guided you through today. So I'm going to hand over to you now. Here's an independent task. Okay, I hope you can see. My video's too big. Anyway, independent task. Are these equivalent fractions? Okay, now it's up to you. I would pause the video. You don't need to draw these out, but here is a couple of, here we go. Here's a couple of titles that might help you out here. So how many equal sections is in each square cut into? How many of the sections are red, and what fraction of each square is red? And then finally, the question is, are these equivalent fractions? So leave that up on the screen. That's what you need to be completing right there. I would say this would take you a few minutes, take as long as you need to, draw out a table if you need to, and then come back and we'll discuss this together. Okay, so you are back already. So let's have a look. The question was, are these equivalent fractions? How many equal sections is the square cut into? Quite easy. You can see that's been cut into 3 sections. How many of the sections are red? So we can see that that is 1 part is red, 3 equal sections, 1 part red. What fraction is that? That is a 1/3 fraction. Looking at our next square, we can see that square has been cut into 9 equal parts. How many parts of that square are red? Well, that's 3 equal parts. What fraction of each square is red? Nice and easy, 3/9. And then this one might have taken a bit more counting. How many sections has this been cut into? 36 sections. How many are red? 12. And what fraction do we have? We have 12 over 36. Now, the bigger question really here that I'm interested in is, are these equivalent fractions? Now, again, you need to be looking at the relationships that we have. I can see a 3, 9, and 36. Definitely something strong there. A 1, 3, and a 12. So, ready to share your answers? I guess you are. Are these equivalent fractions? Yes, because 1/3 is, if we were to times that by 3, is we have 3/9. So 3/9 is 3 times larger, and then we have 12/36, which is 4 times larger than 3/9. And then finally, we can see there that that is 12 times. So 12/36 is 12 times larger than 1/3. Okay, so another independent task. We're wasting no time today. Getting on to our independent tasks quickly. Match the equivalent fractions. Remember your multiples, or remember to use your division technique. Okay, I'm going to give you a couple of minutes, pause the video, come on back, and we can look at these together. Okay, so are we ready to go? I can hear you saying yes. Hopefully you've written them down and used your ruler to link these together. So what do we have here? Let's I think a nice easy one would be 3/4 is equal to 75 over 100. I've had to times that by 25. So 3 times 25 would give us 75. and 4 times 25 would give us 100. I'm sure as a year 6 great mathematician, that was no problem for you, which are 2/3, slightly easier, I'd say. 2 times 4 is going to give me 8, and 3 times 4 is going to give me 12. So we know that that is an equivalent fraction. And then finally, the easiest of the bunch, I'd say, 2 times 10 and 5 times 10 gives us 20/50. Okay, so pat on the back if you got those right, especially the 25 times one. Okay, right. Okay, we've made it to the last question, the last independent task. Mr. Osborne's just going to read it through for you. It says, Mr. Osborne is sharing out some cake equally. He gives 1/4 to Rosie, 1/4 to Rosie, and he gives 4/16 to Jackson. Did Mr. Osborne share the cake out equally? Explain how you know. So before you pause the video and go off and give this a go, it's really important when we're doing worded problems to highlight the key information. So here I'd be highlighting equally, I'd be highlighting 1/4 and the 4/16, okay? And just to let you know, they're actually my children, so we're sort of judging if Mr. Osborne's a good dad or not here. Let's see. So pause the video, come back, and we'll see what the answers are and the explanation. Okay, so back already, fantastic. Let's have a look. So Mr. Osborne is sharing out some cake equally. He gives 1/4 to Rosie and 4/16 to Jackson. Like I said, I would highlight the equally in that question. I would definitely be writing down the 1/4 and the 4/16. Now, if I'm going to work this out, I want to have a look at the relationship between the 1/4 and the 4/16. Now, I can see that the 4/16, the numerator is actually 4 times larger than the 1/4. So therefore, if this is to be an equivalent fraction, that 4/16, so must be 4 times larger, and you're really good at math, so you would have spotted that already. Just times tables there if you're not so good at your 4 times tables, but there you go. You can see that we have an equivalent fraction, and from today's understanding, you would know that equivalent fractions have the same value. They may look different, but they have the same value. So did Mr. Osborne share the cake equally? Yes, he did. So he turns out to be a good dad. Mr. Osborne did share the cake equally. And I know this because the 2 fractions are equivalent fractions. Therefore, they have the same value. So quick recap. Today, you've done a fantastic job. We looked at understanding the term equivalent, and we have worked on very many different equivalent fractions, okay, and looking and understanding. We've used our multiplication and division to help us identify those equivalent fractions, okay. So I'm hoping from today's session you've got a really good understanding of equivalent fractions and how to find them, okay. In our next session, animation, I always do this, in our next session we have simplifying fractions coming up, which will be super. Okay, so see you next time. I've been Mr. Osborne.